Okay. The other thing is, I think, this won't be 75 minutes. I don't think it's kind of long for a video, so more like 60 is my expectation on this one. We'll continue to, we'll follow up because maybe not everyone will see this, or so some of these ideas will be followed up. Okay, so I have a little outline here. I want to go through it on the notepad, but and then we'll go to the computer, and anything comes up or maybe I'll introduce more new things then. I wanted to go through the outline now. So let's see if I can still write. Yeah, okay. I think I can do this. So first thing is, so today, so what is it? What's the date today? It's February. I don't know, 12th, 13th, 2024. I don't know the election number. Things have been a little chaotic, but we'll get back there. So, okay, we have the date. Okay, several things. So first thing I want to mention today, this isn't really any work here, but just a mention it. So Dean Oliver, right, the guy who wrote this book, is pioneer on a lot of the stuff that's still used today. He's not coming to our class to give a talk. I'm just going to mention his book. Chapter 3 is very, I mean, that's the one, like if you just want to spend a little more time reading and working on the course, that's a good place to start. You don't really need to read too much before that. You're welcome to read chapter 1 and 2, but if you read chapter 3, that has a lot of important stuff that's still being used in basketball analytics. And so I would say that's a good place to start. Basically, what it does is it really is the beginning of all the advanced statistics. It sort of tells you why points per game aren't very good and we need to use points per possession. It shows how the team stats are important because when teams win, you know what factors make them win. And then you can look at those players and say, attribute winning to those players, sort of a Bill James idea from baseball, win shares. So it really connects a lot of things, this chapter, and it talks about the statistics, how they computed, and then it also does this thing by looking at teams over history to see which teams are good or not. I think I just said that. So yeah, I'm going to follow up with some of this in the rest of the outline, but that's all I wanted to say. You can start there, and actually, if you want to keep going, we will touch on like 4 through 7 or 8, soon. Not as not everything in them, but some of those ideas. So if you're enjoying it and you want to keep going, that's a good place to be. So chapter 3 through 7 or something. You can always ask me. All right, so now I want to talk about this idea. Usually I do the basketball after baseball, but called Pythagorean wins. We mentioned this, and we'll just write this down because you'll see this. And this is sort of just like net rating. I mean, it sort of comes from those same ideas of points for and points against, and it converts them into a one-loss record, basically, is the way you should think about it. So it actually uses points for and points against, total points for and total points against. Now, when you use those two together, it's a little better than when you're just looking at an offense and counting total points, because what if if you play real fast, you're going to have a lot of points. And just looking at the offense and just looking at total points is going to be misleading. But if you look at the two together, it's a little better because you can see, if you're playing fast, your opponent's going to get more shots too. So it's harder to keep your opponent's score low. So if you look at net total points or net points per game, that I do think that's a bit better. So this is what this does. And in the NBA, it does something like this. It says, and they call it like different things. Let's just call it Pythagorean or Pyth one loss percent. And it's just equal to points of team points to some exponent. Let's put it, did I just lose? Yeah, just because I knew I was going to Okay, hold on, sorry. Yeah, sorry. Points team, let's put a little subscript team here. Let's put it to the R power, points team to the R power plus points opponent to the same R power. So it's a simple equation that just uses points. It uses the percent of points for you squared over the sum of the squares of points for, that you scored and your opponent scored. So you can see if your opponent scored exactly the same as you, then your Pythagorean won-loss record is going to be, half wins, half losses. Now, the actual Pythagorean wins losses are integers, so they have to be rounded. So you just round and make them sum up to the total number of games. And we'll do an example. Maybe I'll do an example here. Yeah, I can do an example here. Now, the R, what's the R? That's the exponent. So the R is the exponent, and this can be changed. And I think it is changed every year or something based on data. And originally in baseball, it was 2, and then it got changed to a little lower than 2. In basketball, it's about 14. So we'll just use 14. So we'll say R equals 14. But you can be sure that they're doing different things and manipulating this different ways. All right. Okay. Any questions? So let's do this. I wanted to do it for, thought I had a good one here, but let's see. Well, we could do a bunch later maybe, but let's just do one by hand first. So, yeah, I have for the Pacers, I was a little suspicious. They have that very high offensive rating, and you know why they do? Because they really do have a good offensive team. Even though they play very fast, they have a high points per possession. So if we do it for Indiana, say, the Pacers, coincidentally, who play at the fastest pace, I think. IND, yeah. So you can use totals or per game, because the per game will cancel right on the top and on the bottom. I would just have, games, 1 over games to the 14th power on top, 1 over games to the 14th. So that would all go away. So it's up to you. The totals will give you pure accuracy, I think. So let's do Indiana. And if I want the percent, you don't have to write all this out like this when you do it. You can make your own names up, maybe smarter names than this. So they had pretty close, pretty even. They're about they're about net rating of 0. Pretty close. So a little better. So 6,801 points scored. And then this would be to the 14th power over 6,801 to the 14th power plus 6,723 to the 14th. And you do this and we get, here, I think I have it over here in my R console. I'm not going to show you, but let me just look up to get the exact number. Might have gone away already. No, I think I got it. Hold on. Yeah, I'm going to do it again. I'm just going to type it in here. So just bear with me. 6,801 to the 14th divided by 6,801 to the 14th plus 6,723 to the 14th. Yeah, so I wanted to get the exact number so that you could verify you got the same thing. So I get 0.54 basically. 0.5403. Okay, they played 55 games. So their Pythagorean wins and Pythagorean losses is given to be, they must sum up to 55. So this is the constraint. This should equal 55. And I just take this times 55 to get the number of wins, right? So we would take 55 times 0.5403 and round this. So let's write it like this: round equals P win. And then use this constraint to get P loss. So if I do that, I get this times 55. Yep. So this says this is equal to 30 when I round it. It's 29.7, but I round it up to 30. And so PL equals 25. And this is actually what it says on Basketball Reference for the Pacers. Okay, so they are using something close to 14 for the exponent here. Now, the Pacers' actual record is, let me see. Where are you, Pacers? Yeah, their actual record is the exact same thing. That's not going to happen very often. Usually, well, the Celtics are 41-12. Their actual record, their Pythagorean is 40-13. So why is this used? Well, it's not always, it doesn't always work this way. I saw one that was off by quite a bit. Houston. Yeah, Houston. Their actual record is 24-29. They've below 500 record, but their Pythagorean record is 28-25. So big swing there, right? 5 games under versus 3 games over. So 8-game difference, 8 games in the standing difference if they were using the Pythagorean record. What do you attribute that to? Maybe they're inexperienced. They don't know how to close games. They get very hot. They're young. They have energy. The players play a lot. Maybe something like that. I'm not sure. Could be different things. So you see, it can be off a lot, and it's used to sort of analyze that sort of thing, like how different. All that really matters is winning and losing as far as this goes. This game of winning goes, and so it's used to look at like how there might be a gap between these main things like points and points against versus the actual winning. Okay, so sometimes it's called luck, the difference, but I think that's a misnomer largely. It really has more to do with, I think, other things, other factors. But maybe, and luck, maybe too. Okay, how are we doing? Are we still, is the recording still going? Incredible. Any questions? All right, guys, good you're here. Welcome to the new people. So, yeah. Okay, so this is one idea. And the thing is, this connects like net rating with wins and losses. So that's why I want to bring this up. Also, we won't have to do it again for baseball or anything else. Okay, next. Yes, offensive and defensive rating versus points per game. Okay, so yeah. O rating, D rating versus points per game. So let's just start with O rating versus P points per game. So let's call this points. I don't know. Points, I think the best way is like this. Okay, so the problem here is, first of all, points per game is pretty clear, right? So this is, and we're all about the teams here for now. So points divided by games, okay? So total points divided by total games. Offensive rating is just points scored. So this is points scored. This is points scored. We'll have to write something different if it's defense, if it's not clear. This is points per 100 possessions. Okay, I'm going to abbreviate it like that, POSS. And, you know, it's the same as points per possession too. It's same information. One is just multiplied by 100. So the thinking here is that this is what really matters. If you play fast, you'll have more points per game. So this could mean good, could mean good, or fast, or both. But this means good. Okay, everybody gets the same number of possessions, more or less, right? Plus or minus 1 or 2 per game. So you don't get more possessions. So if you make good use of your possessions by scoring, then you're good. If you get, say, a lot of possessions in a game, say 120 possessions or some really high number, that means you're going to score more. But it also probably means your defensive stats are worse. Your opponent score gets more opportunities too. So there's no really inherent goodness to playing fast. I mean, it might be a good strategy if you're trying to tire out somebody, you know, or something else, if you're fast guys and that's like your strategy, but just inherently, there's nothing positive about it. It's a neutral fact. So this sort of gets rid of that over here, and this is more ambiguous. So you can see if you include pace in here, if we put in pace too, you can see these three sort of add up. You know what I mean? Like if here, let me make a little game for you. So let's say O rating is high, and say points per game, I'm going to change it to this, points per game is moderate. What can you conclude about pace? You don't have to say anything. I mean, you're not being shown on the screen either if you don't. But if you want to, go ahead. Well, something happened to bring this down to moderate. So pace is probably a little bit low, right? Something like this. And if O rating is high and say pace is high, then this is going to be super high, you know, that sort of thing. So they all, you know, two tell you about the other one. Okay, and so you could just take pace and this, pace and this. But really, since pace is neutral, yeah, really, this I can think of as a function of these two. That's what I wanted to say. Okay, O rating is a function of these two. Makes sense. So if your points per game is not that high, but your pace also, I don't want to put a minus sign. It's not a minus sign. It's just a function of these two. If your yes, if your offensive rating is high, your points per game is low, that must mean your pace is low, right? You're not playing that fast. You're not getting as many possessions as another team, but you're connecting, you're being efficient. You're scoring at a high percent, higher than average percent when you do get the ball. Okay, so we'll go through how to compute these again, just to make sure that we're really clear on these. They are all given for the NBA in the data on Basketball Reference, but still it can be useful to see how to compute them, and also some questions about possessions. Okay, so possessions, like if you wanted to compute something from scratch, I think we did sort of talk about this last time a little bit. So possessions, so there's a way to get them off the Basketball Reference using pace and or just using offensive rating and points. Because if offensive rating is points per possession, I know how many points were scored, I can get possession. So let's just say there's two ways. So for the NBA, you can always, and you could probably find the raw data. I mean, it's easy to do. I can do it. So I'm sure there are websites that do it. So for the NBA, you can get this from, we can derive it from PPP, points per 100 possessions. We're going to call it PPP, which is points per possession. And you could divide the possessions by 100, or you could just multiply the whole thing by 100. I hope this makes sense. And even though it doesn't say per 100, this is what this is. So this is points per 100 possessions. Okay, so if I know points and I know PPP, and that's on there, then I can find the raw number of possessions that they're using, at least for this data. Might not be exactly the same as the actual number of possessions. Another way, but this won't give you the same thing as Basketball Reference, is you can estimate it. And I remember talking about this last time from this, right? We can say it's approximately field goal attempts plus 0.44 free throw attempts plus turnovers minus ORB. So if you use this, basically things will look pretty much the same. The team that leads the league in possessions will still lead the league and stuff, but the data is like going to be off by a percent or two, up to a percent or two per team. Some might be close, some might be a little more than that, but those are two ways to get the number of possessions. Okay, so that's a little side note, basically. I just wanted to be really clear. It does feel good to be able to go to those tables and understand exactly how those columns are computed, I have to say. And then you feel more confident about what you're doing. All right, so yes. So the other thing that's misleading about O rating is, what else is misleading about just looking at O rating? I know this isn't a complete sentence, but it's okay. I'm talking like backwards or something. Misleading about O rating. Another thing is like you need, defense. So defense. So you need to consider both. So a lot of times we want to look at them separately, but you always have to go back and think I need to consider them both. They're equal. And so you can look at net rating, just subtracts the two, and et cetera. Okay. A lot of times though, when front offices are doing their analysis and they're looking for certain types of offenses that they want to build and stuff, they will look at them separately. But as a first look, you just got to remember, I mean, the Pacers, what do you think the Pacers, we'll look at, what do you think the 24 Pacers, 23-24 Pacers offensive rating rank is? I don't mean to pick on them. They're an interesting team, especially now they've made a couple good trades. So they were ranked in O rating. I know you can look this up, so you don't need to, but they were ranked first, I think. No, second. Celtics are first, I think. I think they're second. Maybe, hold on. I have it written down. No, they were first. Yeah, that was just my home bias. Okay, they're first in offensive rating. So they play at a fast pace. They have really high point. Oh, no, they're second. Hey, let me put this down because this is exactly sort of what I'm talking about here. It's a good example. I mean, they happen to be efficient and they play at a fast pace. So this is high and high. So if we just look at points per game for them, they're first. Okay, so they're ranked first. I even have the number here. It's 121.3. and this is first. Who's second? I don't know, but Atlanta's third. I think Milwaukee might be second. I don't know who second is. Boston's fifth. But if I look at O rating, where I don't factor in pace, they're only down a little. And this is not right. Hold on, I'll get there. No big deal. So points per game, they are still first, but it was 123.7. If I look at their offensive rating, points per 100 possession, so this doesn't make a case for there being a big difference here. I will do that in a second. They have this, so 120.9 points per 100 possessions. You can already get the feeling that, like, if I know that I could get possessions out of these two. But it's a little weird because maybe they didn't play 48 minutes per game. So you really need the minutes for that. But anyway, okay, that's them. Let me put a few more of these down just so you can see, and then we can discuss it a little bit. This is kind of an interesting table, although I think I'm jumping around slightly, but yeah, let's just do it now. And so Atlanta, who's I think they're about a 500 team. They have a very high offense too, especially in points per game because they play fast. Their offensive rating is down a bit, so this demonstrates it a bit more. It's 119.0, and they're seventh in the league in offensive rating. A lot of people would say that means they have the seventh best offense. Okay, I'll buy that. That one makes sense. Not the third, the seventh. Yeah, okay, probably true. Then why do you think Atlanta's not, like a 500 level team or less? Maybe, I think defense, right? They don't have a great defense. They're also about a 500 level team. And again, the reason is defense. We can look at this a little more, like where they are in the standings in a second. Let me just add a couple more. So Boston, who is like dominating things basically right now, they're at 120.4. They're fifth in points per game. But their offensive rating is 121.31. Okay, so they have the best offense in the league, better than the Pacers, I would say. Close, a little better. And the reason they go from 1 to 5 here, you might think, like using the old school statistics, you might think this had the best offense. And the Celtics were several spots below them. But once you look at it per possession, you see, no, it's not true. Celtics are first, Pacers are second, okay? Pacers play at a faster pace. They must play at a faster pace than the Celtics for this to happen like this. All right? Because if they all played the same number of possessions, this would, well, I guess they could have more overtime games too. So there could be a few other things, but they probably have a faster pace. All right, let me just do one more. This one's interesting too. Denver, who's a good this year, but has lost a few games lately. They're way down here at 114.2 points per game. This drops them all the way below the midpoint. They're 18th in this, but they play slow, so they play slow and deliberate, and their offensive rating is let's see, 118.2, which it's not a top 10, but it's pretty good. It's 12th in the out of 30. So you can see here's a case where the pace must be slow, or is likely to be slow. Okay, so offensive rating really measures what's important. Just playing a lot of possessions, your team has a lot of possessions. Using net rating takes care of that a bit, because when you use net rating, the defense, you know, you're dealing with having to guard more too, so that sort of takes care of it. So I think for net points per game is actually probably pretty decent. But net rating's also very good too, right? It's probably just as good, probably better. Okay, so yeah, so I want to get through this just to give you an overview before we go to the computer, and just a couple more things. How's everyone doing? So things always turn into maybe more than I want them to, but I can't help it. So how did all this theory get? So the four factors we talked about last time, this was part of Dean Oliver's research and other people's, and we said this kind of seems pretty logical that these make up some good factors that together would predict winning. So how efficient you are scoring and defending, so it's really 8. So we can write 4 factors times 2 for offense and defense. So how good you are at taking care of the ball as well, you know, and then on defense, this would be how well you guard, how well you force turnovers, rebounding, so ORB percent. And by using percent, we take care of the pace situation, DRB. Yeah, so all these things, only things that can kind of happen in a way that, and then the last thing is foul shooting and making the shots and going to the line. So they use this one, and offense and defense. So there's 8. This a lot, I think what he did a lot was he examined good teams and bad teams and really looked at the data carefully over over a pretty big time period, because even though the book's kind of old, and that's the good part about this course is you can read the book, but we're going to use more current data. So this should be, if you're a fan, you'll see teams and players, you know. So he looked over this period, and this is the period, this is where these stats really sort of become reliably available for like all the games and stuff, was 1974. And Dean Oliver stopped, you know, he published the book here about, I think, or maybe 2003, I'm not sure, or 4, maybe. I think it's here. Maybe it's 2003. Anyway, what is that? That's it's like 30 years almost of data. And he would look over time, over all the teams, over all the years. So all NBA teams, so let's write his name since this is going on YouTube. Chapter 3. And then, you know, he sort of, I think I have a feeling he had like theories about this, and then he sort of backed it up by analyzing these statistics over this period. And for me, it's really good for like an intro data analytics course, this part, because what it shows you is you have to adjust for changes in the league. What kind of changes? This would be a good lecture to do in person. So we'll maybe recap some of this because I want your participation too, but let me just keep going, then we'll do some computer stuff. Changes in the league, as well, you know, so by that I mean could be just new batch of players, new rules, yeah, all kinds of things changing, right? New rule change, big things are rule changes as far as the game goes. And then as far as the people goes, the big thing is the players. Players you expect to more or less stay consistent, although perhaps be more slowly increasing in talent, I would think, possibly. Okay, I'm just looking at something else. Okay, so yeah, so you have to adjust for that. And so that's part of what I want to talk about today too. We'll start this and then we'll continue it next time. All right. Yeah, it goes fast. So this is my little outline before we start. So what are some things we can do about dealing with bigger data sets that say are not all in the same few months, like we've been looking at 23, 24, and we want to use it all. We want to use a bigger data set. We have to make these adjustments. So when you look at historical sports data or any kind of historical data, you want to make adjustments. So make adjustments are required, usually required, especially I think in basketball, it seems really clear. So adjustments for changes in the game. So in basketball, in the NBA, rule changes. There are a lot of them. He has a really nice table, which probably be better to go through in person. And you really just have to know that things can change more than, learn these changes, but you might be interested in it. Rule changes. Okay. There are a lot. There are like probably, sometimes it goes a few years with no major rule change, but it seems like it's like one per year, like one significant change per year or something. On average, sometimes many. People, players, maybe other people too, maybe money stuff, I don't know. So there's health and stuff like that. So other things change, and then just randomness maybe. So randomness year to year. Maybe factors we don't understand, but we can consider that, say, this year it was a really low average. Maybe we should compare teams against that average. So, not claiming to understand everything. So let's just say also seasonal or year to year variation. Even unknown. Any year to year variation. Okay. Okay. All right. Okay. I think almost there. So one of the things we can do, and this is it. So some ways to deal with this by adjusting, by standardizing, we'll call it. And I feel like he's overly apologetic for using math language in his book. I'm going to be less so because you all passed the math placement exam and you've signed up for this course. I also understand completely that that this is offensive in a way. But just you can deal with this. It's not that bad. Come see me if you have questions, and don't let it slow you down. So by standardizing, what we mean is, and you'll see, this is no big deal. Instead of say we have points, for say team points, right? Like say I want to look at the best offensive teams. Okay, so if I'm looking here, one of them is, and in the period that he covered is Denver in 1982. Okay, and they have a very high points per game, but then the league had a high points per game. So I'm going to replace this with something like points minus league average. So we'll call this points league average. I mean, you might think that means LA, so maybe I should change it. I'm just going to call it LG or something like that. Points for the league. And then I'm going to also do something. I'm going to divide by, oh, yeah, that I want to make it clear. It's the average of that, right? So how should we represent average? Let's maybe just write the word or something like points for the team minus points. I'm going to write the whole thing down here, league average. And then the other thing is, because the standard deviation changed year to year too, sometimes there's a big variation between the bottom teams and the top teams, and other years it's tighter. We would also divide by the standard deviation This allows you to talk about how much in terms of standard deviations a team is above or below the average. So we're going to divide by this thing and we'll define this more carefully later. So let's just call this SD points for the league. I'll make this clear, so we'll define later. Define below. Okay, I don't want to get too far ahead right now, but I think this is it, okay? So instead of saying they were, like if I'm reading here, and I'll go to this soon. Actually, why don't we go to this now? At the, not the computer, but I have a picture here for you. So, any questions? Yeah, so let's see this table here through this picture now. Where is it? Okay, hold on. Let's see, should we want to do offenses, I think, right? Yeah. Okay. Where the hell? Just give me a second. Mhm. All right, do you see it? Okay, yeah, it needs to zoom in. Let's zoom way in just to make sure we can see the start of it and everything. Okay, so remember, this only goes up to 2002. We're going to do some of the more current ones in class and on the homework, probably the homework 3. So speak up if you can't see the table. Okay, table 3.7, top historical offenses. So you notice 114.3, very high, right? But the league average was pretty high here too in 1982. So still 7.5 points above league average. And then it takes, notice, it's not using raw points, it's using points per possession. So this is really like rolling everything in here now. You're taking your best offensive stat, points per team stat, points per possession, and you're standardizing it. You're taking the league average, you're subtracting it, that gives you the numerator there, 7.5, and then you divide that by the standard deviation. So if I can actually figure the standard deviation out here, right? It must be something like 7.5 divided by 2.65. Let me do that, figure out what it is, and then see if it works. 7.5 divided by 6.25. No, 2.65. Didn't think that was right. 7.5 divided by 2.65, 2.83. So 2.83 is one standard deviation. We have to look at a normal picture, a bell curve, to understand better what this means. We will be doing this, but for now, think about it this way. Roughly 2/3 of the teams are within one standard deviation when you have a big sample. This is when you have a normal sample. So a sample that's based on a lot of data like this stuff will be close to that. So what did I say? It was 2.83. 2.83 is one standard deviation. So in the next one, it changed here. So this is a different standard deviation. If I had another 1982 team, I could compare it and verify that I had the same standard deviation. But you see all these are different years here. So now I can find the standard deviation here for this, doing the same thing, right? Divide 7 points. So it's bigger in 1997. There was more variance among the teams. There were several really good teams, several not so good, and or terrible or whatever. And so you had more variation here. Anyway, this is probably what he's using here in his final table and final analysis of the best offensive teams, is how many standard deviations they are above the average. Okay, you can see these teams. I don't know if this interests you. It doesn't go up very high past 2002. I do remember a lot of these teams. I wasn't really watching basketball much in the 1980s, but in the 70s and 90s I was, and I do remember these teams. They were good. Oh, look. Yes, and this was actually a key rivalry, like the Jazz from the West with these three guys, and Byron Russell and Ostertag and other guys, and then this version of the Bulls kind of late in Jordan's career, toward his end with the Bulls. But still they were excellent. He was still, the best player in the league. So here you are. And let's see, do we get the same number? You know what I'm thinking? This is on a linear thing, right? So if I take 7.7 divided by 2.32, that should equal 7.0 divided by 2.11. It's the same standard deviation. Let's try it. We don't have to be in that much of a rush. So 7.7 divided by, I forgot already, 2.32. 3.32. And now take 7.0 divided by 2.11. 3.32. Okay, so yeah. So this is the standard deviation of the offensive ratings. Okay, all right. I want to go another 15 minutes and then we'll stop. Let's go to the actual data. We'll come back to this next time. I'll talk more about that 2/3 rule. Well, 2/3 are within what I was going to say. 2/3 are within one standard deviation, and 95% are within two. You can think of it about that way. So these are these are in top 5%, anything over 2 here. Roughly, it's an approximation, but maybe these are 2 of all the teams in the NBA, okay, over time. And I mean, these are top ever, okay? And you see the top ever, even, you only have a few that are over 2 here. So maybe it's not very normal in a sense then, but only top 5, maybe I would expect more to be over 2, but maybe it makes sense. I have to think about that again, but you can see anyway, 2 means extremely good. As you get down closer to like 1, it doesn't seem as impressive to me, but still, this is his list. So we'll think about that next time. Yeah, it only goes down to 25. When I did it for the teams after 2002, I get a lot of new ones. Okay, so there are a lot of teams since then, the Golden State Warriors, a lot of other teams, the Rockets with James Harden. There were a lot of teams that are now in the top 10 from recent years, but still some of these are as well. So, okay, let's go to Basketball Reference just a little and look at some of this stuff, and then I promise we will wrap this up at 2:30. I want to wrap it up at 2:30. Okay. So the last thing. Oh, let me show you one more picture before we do this. let's bring this other thing up here. This is from Dean Oliver. So, just so you can see this, he was thinking probably didn't want to use standard deviation, but or maybe he did. But he did look at it and saw it was changing and wanted to use it in this analysis stuff. So, remember, he started around 1974. And let's see, one of these is offense and the other is defense. Defense is the open square and offense is the closed diamond. Let's just focus on offense then. So this is standard deviations of team offense and defensive rating. Standard deviation, yeah. So we were seeing before that both times we got about 2 for that. Oh, and we got 3 in the 90s. Remember 3.1, and before it was 2, I don't remember now, but 2 point something. So for the 80s. So yeah, here they're right here. Those numbers are on this, right? So you could see standard deviation went way up, sort of peaked out in the late 80s, went down a little, stayed pretty high though. From the late 80s to the late 90s, went down again. He attributes this to several things. I don't want to mislead, so I'm not sure which ones he thought were the most important. We can go through that again. I know he mentioned like the fact that there was like dilution in talent, and that may have caused the high variation, but I can't remember why. Does anybody know why here? Maybe there were some bad teams. I don't remember. Anyway, just it's a cool picture also in that chapter. And that's all it means. Take the standard deviation of the offensive rating and plot it versus time. We can now do these from here and complete his picture. I'm sure somebody has. It's not that big a deal, not very hard, but we'll see. We'll see. Yeah, we'll see what to do. Okay. Just 10 minutes, but let's do a little bit before we stop. Okay. Let's share our, do I have it? Yeah, let's see. I think I have something here to share with you on. Okay, so you're seeing the stuff here that go ahead. Go away. Okay, so so these were my standard deviations, right? 2.8 for the net offensive rating in that 1982, meaning, yeah, 2/3 of the team were within 2.8 of the average, and then yeah, and then 95% or within or more, 5.6, whatever. Okay, yeah, so I got this stuff. Let's see, can we play with this or should we go? I don't want to have to go back and get it again. I thought there'd be more time and was going to do that. Let's see what we have here. What could we do? Yeah. Yeah, okay, so let's look because we did. Yeah, okay, so let's get the hmm. I think we're pretty good. Okay, I'll tell you what, one thing. Let's do one thing. So let's read in the file and just find the, do I have net rating for that? Or offensive rating? We can compute it, right? We can compute it from the stuff we have. So, so yeah, let's just see if we can do this. So I have the files, I think, hopefully here. So there I list the files, and otherwise we'll just do it next time. But what I want to do is show you for, say, this is just the current season 2024, and it's up to today. I put Feb 13th in there, and NBA team Feb 13th. Oh, those are totals. Advanced team, I think that's still intact. So that should have my rating, right? So let's do that, yeah. And let's just see what the league average is for right now and see and standardize the column, and then we stop. Okay, should be able to do this in 6 minutes, just bear with me. If not, so, okay. So let's load it in again, new time. So let's call it NBA, say equals read.csv and NBA add. Yep, CSV header equals true. I hope this works. Oh, okay. I think it's okay. Yeah, okay. So now we probably can super clean this up. So let's look just ahead of it. Yeah, so all I want to do is maybe I'll keep offensive rating, defensive rating, and team. Okay. Notice too, here's Pythagorean win, Pythagorean loss we talked about. And you could see Celtics, like I said, there were one more. I like that with my team to see it not be less than this, right? Because you don't want to be less, but there's some randomness, so it's not bad to be off by one or two. So okay, let's now let's get rid of everything except team, offensive rating, defensive rating, and just see how to do these. So let's just keep a reduced version of it. You can use the select command, for example, and team, don't forget team. So remember too, the command is NBA team, and now O. And let's also keep wins and losses too, just to see if there's anything interesting there. Okay, I don't want to see. Okay, and now let's do it again. Okay, that looks a lot better, easier to deal with, right? Okay, now let's standardize both the O rating and the D rating, not the ones and losses. We'll just keep that. So I need the league average. I can get the league average. It might be here at the bottom of the table. I don't know. You can type tail NBA and see the bottom. Yeah, it does have the league average. So we can just use the league average. Let's see. Or I could just, you take the mean of everything. That will do the same thing. So, yeah, or just put in 115.9. So there's a lot of different ways we can do this. Notice the league average, they're the same. Agree? That's got to be true, right? Otherwise you have one team playing against nobody or something like that. Okay, so let's standardize it. First, let's make a column for points above league average for both of them. So let's add to that. So let's take NBA and let's add to it. So that's mutate NBA, and we just adding columns to the end. So I'm going to say OTG above LA, league average, league. Don't want anybody getting confused. Okay, and what should this be? This is just ORTG minus, I can just use that number. It's not any different. I don't think it's stored to more accuracy or anything. Maybe it is. I don't think it is. If you want, you could just put it in or write mean. Yeah. Could do this. If you don't trust that, you could write mean ORTG. That would also work. No, sorry, I gotta subtract it. ORTG minus mean ORTG. Okay, that's that. Now, I don't have to worry about rounding it because I'm not dividing. Okay, so it should keep its precision. And DRTG, I'm making these too long, these names. This would be DRTG minus mean DRTG. Okay. Okay, I did need to worry about rounding. So it does keep the precision if you do that, I think. Oh, no, it was the mean, I think. Maybe the mean used all of that. Okay, it's okay. I can round them later, or I can still round them now. So no big deal. But you can see we can now arrange these. I'm a little bit feeling rushed, so let me just go a little bit further. I want to select, so I'm going to select all of these, and I'm going to use this transmute command. Maybe this is helpful because if you're doing homework or something, you can go to the video and see how to do these. So now I'm going to do, I'm going to just call it O rating. What's a good name? Let's just say above or something. Still too long. Equals, let's round it now. O rating above league. And let's round it to 1 decimal. Okay, and I want to do the same for the other one too. But I'm actually going to do this, and that will take that out, I think. And I can put this in later the way we did before. Okay, so let's put the 1 loss over here. Okay, and now to do the defensive, I'm just going to go back to here and just here, and just make sure I round this first and change the name. Defensive rating above, yeah. So a minus would be good here. And round this to 1. And I'm just adding this to the end of the table, so I don't want to alter this. Okay, yeah, so that looks good. Notice these are positive. That's bad, right? The defensive, so head's more interesting maybe. So Celtics 5.4 above, and they're holding their opponents to 4.1 below. So it's actually this minus this is a nice standardized net rating. Actually, yeah. Okay, the last thing you would want to do is now divide by the standard deviation to get how many standard deviations there are above and below. If you need to go. We have 10 more minutes. I'm just going to be another couple minutes. I want to complete this so that you see this last step in case you want to reference the end of the video for your homework or something. So the last thing is to do it in terms of standard deviations. So I can now just add standard, like something for that at the end. So let's do them one at a time just to make sure I don't screw it up. So let's just say ORT over in and STD or SD sometimes. So let's do it above. These are dumb names. I'm sorry. But just so you have the idea. And all we have to do now is divide ORTG above by the average standard deviation. You're not going to see what it is. If I do this, that's okay. I will want to round it too. So let's just put in SD, lowercase, and I don't need this, SD, and just put in ORTG, not above. I don't want to think about it. I was going to say maybe it doesn't matter, but I don't want to think about it. So here round and put in a 1 here. Okay. Yes. Okay. So you saw those other tables, right? And you saw teams like at 1.9, that were down. And I said that didn't seem that like they would be in the historical top table. But look, the Celtics are pretty good this year. Let's face it. They're at 1.4. Okay. So now it's starting to make more sense. They're peaking at the historical table, but they're not quite there. Yeah, the lowest in the top 25 from back here is 1.7. And I mean, there's got more teams in there that would be in that table. So they're probably not a top 50 team yet in offense yet. But the good thing about the Celtics is they're very well rounded, and in net rating, they might be a top 25 or 50 team. Okay. I hope this is clear. We could do the same with defensive team. If you want to see the whole table, and of course, I don't advise you using those names in your assignments and stuff. Use whatever you want. Let's just see the whole table here, so in case there's anything interesting. And let me just expand it a little bit so we can see the whole thing, or enough of it. I don't know if this bar is blocking you. Let me just take out a couple teams there. Yeah. So, yeah, we'll just take out a few of the teams at the bottom for now. So do you see anything interesting? Their win-loss record here. I mean, look at the teams who have won the most games. So they do seem to correlate pretty well with the teams here. We can arrange in terms of win. So let's display it by arranging in terms of win. That's the last thing to do. NBA descending win. And look at the top now. And yeah, I see who's low. Remember, we're only looking at offense. So Pacers have a good offense, we said, and they don't have a good defense, apparently, or they play fast. No, they have a good offense. So they do have defensive issues, apparently. Yeah. What else is interesting here? Well, Wolves are pretty low in offensive rating. They have a very good defense, so that makes up for their offense. So they're, second best team right now. Nuggets, very, very good defense. They play at a slow pace, but of course, that shouldn't affect this so much. It should affect the points per game, but not the offensive rating much. But they're better defense than offense, I think. All right, guys. If you have any questions, let me know. Any questions before I stop the recording? All right, no class Friday. I'm going to stop the recording, and then if you want to ask questions after, feel free to stay. Stop share. Stop recording.